Hello friends, in today's video we're going to be discussing queues. We're going to be seeing why do we need them and how we can use them within our .NET Web API. There was a lot of questions about queuing and how does it work, etc, etc. So in this video we're going to be diving deep into that and understand how it can actually integrate within our .NET Web API. If you'd like to learn more about .NET, AWS or Azure, please make sure you like and subscribe. It will really help the channel. Now let's jump into it. So before we start into the code, let's understand the concept behind queues. So let's say here I have application 1 and application 2. So I'm just going to call this app 1 and I have here app 2. And both of these, for example, for the sake of this conversation, are .NET Web APIs. So this one is a .NET Web API. This also a .NET API. This can be a Azure function, or actually this can be a Lambda, or this can be a MVC application. It can be anything we want, and vice versa. So also the first one can be a Lambda or an MVC application. Both of them are the same thing. So, but for the simplicity's sake, we're just taking a web API example. So I have here these two applications, and let's say what I want to send between application 1 and application 2, some type of information. So something happened here, let's say like a new user have registered or anything. And once a user have registered, I want to notify that the application 2 that this user has registered. And now, for example, they get access to a certain feature for any reason. So how can I do this? So there's multiple ways where I can achieve this. The first way, which could be a simple HTTP request. So we can have here, for example, HTTP request. But if I do a HTTP request, this means if for any reason my app 2 is not available, I have to delegate a lot of the logic to app 1 to do all of the retries, to handle all of the different backoff policies. So for example, if app 2 is being down, for example, for like 3 days, my request will have to stick for within app 1. App 1 will need to keep that request pending for 3 days and then send the request for app 2. So as we can see here, app 1 will have to carry a lot of logic in order for it to make this application, or basically this app 2, up to date with whatever happened here. If for any reason app 2 is not available, maybe it could have a lot of traffic or anything like that, app 1 will need to basically do some kind of a circuit breaker for app 2, basically to prevent bombarding it or doing a DDoS attack on app 2 for it to update and then wait a bit of time and then actually send the results. So we can see there's a lot of potential of overhead that we need to implement within app 1 in order for us to ensure that the communication between app 1 and app 2 has happened. So how can we resolve this? One way of resolving this is relying on a message broker. And this message broker, we're going to call it a queue. So very simply, a message broker is basically, we can think about it as the mailman. So what happened is whenever app 1 wants to send something to app 2, what it does, it is create a message. It gives it to the mailman, and then the mailman, it becomes its responsibility to actually deliver the message to app 2. So app 1, once it actually gives that message to the mailman, it's not actually responsible anymore. It done its work. It has confirmed that the message has been delivered to the mailman, and now mailman is going to be responsible for sending the information or that message to the app 2. And now we have removed all of the overhead that app 1 will have to do in order for it to ensure the communication between the two together. Here we can see that the mailman and the app 2 will be able to handle all of this communication. So what does this mean? So let's say, for example, app 2 is for any reason not available. It's being updated, a lot of requests, whatever it is. Once the message is with the mailman will try to deliver it to app 2. If it does not deliver, it will put it back with, it will keep it with the mailman. It will try again. If it does not accept it, it will put it back within the box of the messages. It will try a third time, for example. If it doesn't work, in this case, what it can do is it can put it into a box, which is called dead letters. And the dead letter queue is basically all of the messages that will not be able to processed by the app 2 function. And this will allow us to have an overview about all of the failed attempt. Even the messages inside the DR queue, we can even run them again and try to send them again, but that's a different story. But here we can see that we have eliminated the need from app 1 into handling all of the overhead to send a message to app 2. And we have used this mailman. And in the real case scenario, a mailman here is called a queue. And queue is pretty simple. It's basically, we can think about it as a tunnel or basically a mailman, which carry a lot of messages. And its goal in life is basically to make sure these messages are delivered to the recipient. And that's it. There is nothing else that we need to worry about. Once the app 1 sends a message, it will go to the queue. Once the message is in the queue, app 1 has finished its job, then it's up to app 2 whenever it's up and ready to receive that message and process it. Once app 2 to accept that message, it will be removed from the queue. As simple as that. We don't have overhead here, we don't have overhead here. All of the management is going to be happening with a queue. So we might think, okay, that's great. We know what is a queue and now we know how it works. But what is a DL queue? So the DL queue is a quick summary. If a message goes to the app2 and for any reason app2 is not able to process it, it could be like it contains wrong information, app2 is down, or for example, there is some kind of configuration issue within that message, whatever it is. After a certain amount of time of retrying to process this message, it will go to the DL queue. DL queue will store this failed message, and basically we can create some kind of notification system saying we're trying to send this message to app2, but it's failing. Please take a look at the message inside the DL queue, and that way we're able to debug and understand why it's failing. And if for any reason it was related to the app2 which is failing, we can update app2 and then retry pre-process this message, and that way we'll make sure it's delivered. So we can guarantee delivery from the messages that app1 will send it to app2. The queue will be able to guarantee that, and will be able to actually understand what's going on for every single one of these requests. If we're going to be relying on HTTP request, we're going to have to write a lot of logic to capture all of the failed attempt, the backoff policy, the circuit breaker, whatever it is, in order for us to have similar logic to that. So this is in simple terms, why do we might want to use a queue in order for us to have communication between two different applications. So now that we have covered that, what are the ways that we can actually create a queues? And there's a lot of ways. So we can use RabbitMQ, we can use SQS from Amazon, we can use Service Bus on Azure, we can even utilize Kafka. I don't recommend it, but we can use Kafka. There's a lot of different ways we can actually create. And just to make stuff simple, what we're going to be doing today is we're going to be relying on using SQS, which is on Amazon service. What we're going to be doing is we're going to be going through step by step on creating a simple queue on AWS and utilizing it. So this is my AWS dashboard, and as you can see, I have here simply queuing service. If I don't have it here, I can just search for it. I can just type queue, and the first one, it will appear a simply queue service. So I'm just going to click on that, and here we have an old queue that I've created before. I can create another one. So what I want to do here right now, I'm just going to click on the create queue button, and here we can see I have the two different types of a queue. I have the standard and I have the FIFO. FIFO is a first in, first out, which means it guarantees the order of the messages. It has its benefit, specifically if you have some kind of an ordering mechanism that in order for you to handle the messages. If you don't really need that types of ordering or basically exactly once processing, what you can do is you can actually rely on the standard. It's way cheaper and it's much more easy to utilize. Both of them, to be fair, are easy, but the standard is basically make more sense. So I'm just gonna call here F1 demo queue. I can call it whatever I want, to be honest. So now that I have given it a name, these are all the different configuration. I'm gonna leave that all the same. I'm not gonna change anything. Here we can see the retention period, which means that this is the amount of time the message will stay in a queue before it goes to the DL queue. If it's not processed, I can change it to a maximum of 14 days. 4 days is also plenty of time to check if something is not right. Encryption, I'm gonna enable it by default. I'm gonna utilize SQS managed encryption. You don't really need to worry about that. Amazon will take care of all of the different encryption mechanism. And for the access policy, I'm gonna use basic. Basically, it's gonna allow my account right now to access it. And I'm not going to have any lead drive. I'm not going to enable that lateral. If you're interested in that lateral queues, please let me know and I'll make sure to create a video covering that lateral queues. And I'm going to have here a tag. I'm just going to say SRC. I'm going to say YouTube, and that should be it. And I'm going to click on creating queue. And now we can see my queue has been created, which means that if I go back to my diagram, this item here has been now created on Amazon. And now this item, if I want to send any information, we can see that this is the URL that I can actually send messages to, and it will be responsible for delivering the messages to whatever service it's going to be needing. So as simple as that, this is how we can create a queue and start processing. Of course, there's different ways to create a queue. You can utilize AWS. I can't remember the language they use to create it through theirs, infrastructure as code. I highly recommend Terraform, but to make this simple, we just utilize the graphical user interface to create this queue. So now that we have done that, now let's jump into the code and see how we can actually start processing it. So what I have here is I have a very simple web API. We have built this a while back. If you're interested, I'll link the video down below. But basically, this web API has two endpoints, drivers and achievements. And within these two web APIs, basically, I have a CRUD operation to create a driver and get their and basically manage their achievements as well. So what we're going to be doing right now is we're going to be creating a service. So here, if we go back to the diagram, So this is my F1 app, and basically whenever a driver is created, so I'm gonna say driver, I'm gonna notify another application. I'm just gonna call it the FIA, and I'm gonna notify it. Simple as that, nothing really else just than notifying. So here basically these are the two items that I'm gonna be building right now. So let's start with this one. If we go back to Rider, what I want to do is I'm gonna create a service right now that's gonna allow me to use the queuing and use SQS inside my web API. So let's see how we can do that. So inside my terminal, I'm gonna make sure I'm in the Formula 1 API, and I'm gonna put add package AWS SDK.SQS, and now it's gonna install this. It's gonna take a few minutes, few seconds, and now we can see it's installed successfully. So right now if I come here and I check my CS Pro, we can see here I have my SQS NuGet package available for me to use. Perfect. Now inside my root directory, I'm going to create a folder called services, and inside my services folder, I'm going to create a new interface. I'm going to call it IQ service. I can call it whatever I want. And this service is going to be pretty straightforward. All is going to have a single message, a single method called send function, which is going to be task boot send message. As simple as that. Again, here, what I'm going to do right now, I'm going to create a class that's going to implement this. I'm going to call it the Q service, and it's going to implement the IQ service, and it's going to say that you need to implement the missing member. So I'm going to do that, and we're going to make this as async. And now I'm going to introduce the logic to send a message to the queue, and we're going to be seeing how easy it is to send a message to the queue. So first things first, I'm going to check if the message exists. So I'm going to say if string dot is null or empty message, I'm going to throw new argument exception, no message to send. Perfect. So now what I want to do is I want to start building my message. So I'm going to put var message request equal new send message request. And here inside my message request, I'm going to define the following. First of all, I'm going to specify the queue URL. And this queue URL is going to be available from here. So I'm just going to copy this queue URL, which I just have by creating it on AWS. I'm going to put it here, and then I need to provide the message that I want to send. And I'm just going to pass the message that's going to be sent. Perfect. So now this is my message request. Next, I'm going to be needing a client. So how can I generate a client? So what I'm going to do here is I'm going to utilize the construction initialization. I'm going to put private read only Amazon SQS. I'm going to call it SQS client, and I'm going to initialize it through the constructor. It's going to be Amazon SQS. I'm going to call it SQS client, and here it's going to be SQS client equal SQS client. Perfect. So now that I have initialized my client here, what I'm going to do here is I'm going to utilize this client in order for me to send this message. So we're going to put var response await SQS client, send message async, and I'm going to send this request, and I'm going to say if response status code is not going to be equal to OK, I'm going to return false, else I'm going to return true. Perfect. And this is it. Actually, yeah, this is it. This is the entire service that I need to create. Very simple. So now that I have done this, now I'm going to go to my program.cs and I'm going to inject it here. So first of all, I'm going to inject my services. So here it's going to be the IQ service and the Q service. Second, I need to inject my Amazon CSQS service, so I can do it here. So here what I'm going to do is going to generate my new SQS client. So I'm going to put generate SQS client. I put var SQS client equal new Amazon S client, and this will take the new AWS credentials. So I'm going to put a new basic AWS credentials, and as we can see, it's asking for the access key as well as the secret. So I'm just going to inject those into my program.cs and my app settings, and I'm going to take it from there. So we're going to use the builder. So I'm going to put builder .configuration.get section, and here I'm going to specify the section that I want, which is going to be AWS access key ID .value. It's not created yet. I'm going to create it, and the other one which is going to be for my secret. And lastly, I'm going to specify my default region, and I'm going to say Amazon region endpoint AU West 1. Perfect. So now what I'm going to do is inside my program.cs, actually inside my app settings, I'm going to create a new section, and this new section is going to be called, what did we call it here? AWS. I'm going to call this AWS, and I'm going to specify the configuration here. So the first one is going to be the access key ID, and the second one is going to be the secret access key. Perfect. I'm just going to copy paste this off camera, and then we'll continue. So now that I have added my access keys and my secret, so now basically what I'm doing here is as I'm generating an SQS client, I'm relying on basic credentials I have my secret ID, my access key ID and my secret available. I'm defining also my default region, and this region will need to match to this region here. So if you take a look here, I've chosen this region, and we can see it actually matches the region that I have here. So all of this will need to match. If you're wondering how you can create your keys, what you can do is inside your IAM, you basically create a new user and you give it the right permission that you want. So this is what you need to do. So once you have done that, as I have done right now, let's go back here. And now this SQS client will need to be injected. And the way we do it is pretty simple. It's going to be build.services.add singleton, and here we're gonna say it's gonna be for the Amazon SQS, and we're gonna pass the SQS client. As simple as that. And with this, I'm able to actually utilize my IQ service, and now everything should be hooked up. So what I'm gonna do right now, if I'm gonna go to drivers, and I'm gonna do something which is really simple. First of all, I'm gonna inject my service here. So I'm gonna put private read-only IQ service. I'm gonna call it _Q service. I'm gonna inject it through the constructor. And what I'm gonna do right now is whenever I'm adding a driver and after it has been saved, all I'm gonna do is I'm gonna put await _Q service .send message, and I'm gonna say driver added, and I'm gonna pass the information of the driver. So I'm just gonna say driver dot name, first name, and the driver's number, for example, driver last name and the number. Yeah, that's it. We just send this message, and now we can actually try it out. So I'm gonna run this. I'm gonna open it up in my web browser. So we're gonna go to localhost 5000. Now, as you can see, I have here my CRUD, and when I want to add a driver, I'm just gonna add a new driver. I'm just gonna call it Mohamad Lawan, and I'm gonna say number equal 87. Oops. 88. I'm gonna leave everything as is, and what I'm gonna do also, I'm gonna go here and I'm just gonna add a breaking point here inside actually my IQ service so we can monitor it here. So now let's click on execute, and as we can see, the request hit here inside this, and now if I jump into the code, we can see here that the response came back with an OK, which means everything is successful. And now if I go back to my web browser and I check it here, we can click on send receive messages on AWS. We can see there is one message available, and if I pull this message and if I click on this, we can see here driver has been added, and this is the record. Perfect. So now we know that my API is actually connected to SQS. If I come back here and we remove this breaking point, I'm just gonna add a few other drivers so we can see like we have a list of them. So I'm just gonna add here Mohamad 1 and execute 2 and 2, execute 3 and 3, execute. And now if we come back here, we do the polling, we can see that we have 4 messages available. Perfect. So now I have my information, it's all being stored. If we go here, all of my information are now in the queue. Now what I want to do is I'm just going to create a very simple application that's going to actually consume this information. Now let's see how we can do that very easily. So let's open my terminal. I'm going to create a new web API. I'm going to call it .NET new web API controllers, and I'm going to call it FIA.API. And it's been created. Now let's open it up in Rider and we'll take it from there. Okay, so now that our application is working, what I want to do here is I'm going to create the logic in order for me to listen to the queue. So first of all, I'm going to add a package similar to the one that we have installed before. I'm going to put .NET add package. It's going to be the same package, AWS SDK SQS. Perfect. So now if I come here, right click and check my CS proj, we can see it has been installed successfully. Perfect. Similarly to what we have done in the app settings, I'm going to create a section for AWS, and it's going to contain the same sections. I'm just going to copy paste them from the other application. So now that they have been copied, I'm going to go to my program.cs and I'm going to continue the configuration from here. So right now I'm going to add a new directory. I'm going to call it services, and inside the services I'm going to add a new class. I'm going to call it SQS background service, and here basically it's going to inherit from the background service. We need to implement the method, and now here what I'm going to do is I'm going to be listening to the SQS coming in. So before we do that, let us just add this as a hosted service inside our app settings. So I'm going to go to my program.c. I'm going to put here build.services.add hosted service, and we're going to say it's going to be the SQS background service. Let's fix the references, and that should be it. It should be running whenever it's executing. So now I can start working on listening to those messages. So first of all, I'm going to start by defining the constructor in order for me to read the configuration that's needed. So I'm going to put private read-only I configuration. It's going to be underscore configuration. Of course, there's so many other ways you can do that. I'm just using the simplest one for now, so we don't make the videos a few hours long. And then once I have this here, so we're going to first define our client. So I'm going to put var SQS client. Let's fix this references. And let's start getting the credentials. So I'm gonna put here, it's gonna require new AWS basic credentials. And here we're gonna require the access key and the secret key. So again, we're gonna rely on the configuration. I'm gonna say .get section. I'm just gonna copy this from here. So basically we're saving a bit of time. Let me copy all of this. And here we're gonna have to rely on the underscore configuration. Perfect. So now that I have this in place, the next step that I want to do is I want to utilize the SQL client in order for me to listen to it. So I'm gonna put while not stopping token is cancelled request. So it means that the background job is still running. What I want to do here, I'm going to start receiving the messages. So I'm going to put var request equal receive message request. Let me fix this. And here I'm going to remove the maximum. Actually, let's keep it for like 100. And let's make sure this is the right. So I'm just going to make sure I'm copying it back from here. So I'm going to go back to my F1 queue, copy this URL, and I'm just going to add it here. Perfect. So now that I have this in place, now what I need to do is I'm going to start processing this request. So I'm going to put SQS client, receive message async, and I'm going to utilize it. Or what I can do is I can just make it await and remove this. And let's make this as an async. So now that I have this in place, now what I want to do is I want to process the response. So I'm going to say if it is okay. So I'm going to say if response dot, so if response dot HTTP status code dot okay, then what I want to do is I want to start processing those messages. So I'm going to put for each message in the response dot messages. All I'm gonna do right now is let's use a logger. So let's define a logger here. So private read only I logger of type SQS background service. I'm gonna say it's gonna be a logger, and let's initialize it through the constructor, and then I can refer to the logger here. I'm gonna say underscore logger dot log information, and we're gonna log the message. So dot body. Perfect. And this is gonna be it. So now what I'm gonna do is I'm gonna run this, and I'm gonna pay close attention to the console, and I should be able to see the messages coming in, and we have an error. Let's see what the error is. Okay, I have an error in the configuration. I'm just gonna put 10 instead of 100, and let's run it again. And as we can see, my messages are arriving. All of these messages that I sent previously. So what I'm gonna do is I'm gonna run my API again, and I'm gonna send a new request with a new driver information. So I'm gonna say here, I'm gonna call this, I don't know, Lewis, and here Hamilton. Okay, number 44, and send. And now if I go back to Rider, go to the other browser, if we go down, we should be able to see the message here. And as we can see here, Lewis Hamilton is actually has been received successfully. Okay, perfect. So now this means that my application is working, and my full flow of sending a message, receiving it by the queue, and then receiving it by the application is working successfully. So this has been a very quick introduction on SQS and .NET Web applications. We were able to see how we can actually send messages to a queue, and how we can actually consume it, and how we can utilize SQS within our .NET Web API. Within the next video, we're going to be discussing topics and how we can actually utilize them, how they will integrate within a queue, and how we can actually consume them within our applications. If you'd like access to the source code, please make sure you support me on Patreon or become a member on the channel. If you like this video, please like, share, and subscribe. It will really help the channel as well. If you have any questions or any clarifications, please make sure you put them in the comments down below. As always, thank you very much for watching, and have a great day.